Hello there, and welcome to 4-4. Today we're going to be talking about graphing functions. And we're going to really do three things. We're going to talk about how do we graph functions when we have a limited domain, how do we graph them when we have a domain of all real numbers, and then how do we deal with story problems. So the first example that you see here is a function with a limited domain. So you see the function there, and then they tell you the domain values that they want you to use. So the very first step here is to solve for y in the function. Now we won't always have to do this. Sometimes it'll already be solved for y, but in this case it's not. So we need to solve this function for y. Now we did this back in 2-5, so all of you back in 2-5 wondering when are we ever going to use this? Here's your answer. So I need to get y by itself. So if I look at y, what's happening to it? Well, it's being times by -3. Nope, not first. Yeah, first. And then it's being added by x. So the first thing I have to do is subtract x. So let's do that. So then I have -3y equals -6 minus x. And then I have to divide by -3. So I'm going to divide by -3, and I'm going to do each thing over here by -3. So then I have y equals, and -6 divided by -3 is 2, and then I have a negative divided by a negative here, and that's x over 3. So now that we have it solved for y, we're going to take our function and put it in a table. Now I know that these two look a little different, but they're the same thing. All they've done is put a 1 in front of the x to get 1/3 x, and then switch the order, which is legal because it's addition. So then in my table that I create, I put the x values that it gave me in my domain, and all I'm going to do, and I believe that we did a little bit of this back in chapter 1, is take these values and plug them in to my function. So 1/3 times -3 is -1, plus 2 is 1. So then I have the ordered pair -3, 1. Then I do 1/3 times 0, plus 2. Well, 1/3 times 0 is 0, plus 2 is 2, so then I have the ordered pair 0, 2. Then I plug 3 in there. 1/3 times 3 is 1, plus 2 is 3, so I get the ordered pair 3, 3. And then I plug in 6. 1/3 times 6 is 2. 2 plus 2 is 4. So I get the ordered pair 6, 4. And then the last step, after I've created the table, shown my work of course, got my ordered pairs, is to graph those ordered pairs. So I had -3, 1, 0, 2, 3, 3, and 6, 4. Now I'm not going to connect those dots because I have a limited domain. When I have a limited domain, I do not connect the dots. I just place the points on the graph and I am done. Now the next thing you'll see is how do we graph when we don't have a limited domain, but in fact we have a domain of all real numbers. Now it's very similar to what we just did, except for we're going to choose several values of x, and I'll tell you what those values are. Then we're going to, again, put them in a table, find our values, plot the points, and then we connect the points. So when we're doing all real numbers, we connect the points. When we're doing a limited domain, we do not. So let's look at an example here. Now this one is already solved for y, so I don't have to worry about solving it for y. So then I'm just going to create a table. So let's go ahead and do that. I'm going to put my x values over here, my work in the middle, and then my ordered pairs. So here's my x values. I have y equals negative 3x plus 2, and then my ordered pairs. So when we are not given values, we're always going to use the same 5. Negative 2, negative 1, 0, 1, and 2. Those are going to be my x values. So I'm going to go through the same process here. I'm going to plug each value in to my equation. So negative 3 times negative 2 is positive 6, plus 2 is 8. So my ordered pair there would be negative 2, 8. Plug in negative 1. Negative 3 times negative 1 plus 2, that's positive 3 plus 2, which is 5. So then I have negative 1, 5. Then I have negative 3 times 0 plus 2. Negative 3 times 0 is 0, plus 2 is 2. So then I have 0 and 2. Negative 3 times 1 plus 2, that's going to be negative 3 plus 2, which is negative 1. So I got 1, negative 1 is my ordered pair. And negative 3 times 2 plus 2, negative 6 plus 2, which is negative 4. So then I have 2, negative 4 as my ordered pair. So then I'm going to go ahead and I'm going to plot these points on the graph. So I start out with negative 2, 8. Then I have negative 1, 5, 0, 2, 1, negative 1, and 2, negative 4. Now since this is not a limited domain, I need to connect my dots. I'm going to draw a line through those dots. Make a nice long line. For some reason people like to make really short lines sometimes. Make a nice long line through your points and add arrows to both sides to show that it goes on forever in both directions. So really the only difference between a limited domain and an unlimited domain is that we connect the points that we graph. Okay? And then the final thing is story problems. Now, when we have a story problem, we're going to follow a very similar process, but we have to think a little bit more about the numbers that we pick for x. So here we have a mouse that's running 3.5 meters per second. The function y equals 3.5x describes the distance the mouse can run in x amount of seconds. Graph the function. So we're going to create ourselves a table again. Let me get my straight line tool here. Okay. And my function is y equals 3.5x. And then I got my ordered pairs. Now, I can't just choose negative 2, negative 1, 0, 1, and 2 here because it doesn't make sense to have negative seconds. So I have to choose positive values, and I want you to choose at least 4 positive values. Now they really can be anything, but if we read the rest of this problem, it says use the graph to estimate how many meters a mouse can run in 2.5 seconds. So we know that we need to at least be able to see what happens at 2.5. So I'm going to choose 1, 2, 3, and 4. Now I don't want to choose 2.5. I know that I could just plug 2.5 in there, but I'm going to estimate at 2.5. So typically I'm just going to use whole numbers in my x values. So then all I'm going to do from there is plug in each value and get ordered pairs. So I have 1, 3.5. If I plug in 2, I get 7. So I have the ordered pair 2, 7. If I plug in 3, That's going to be 10.5. So I get 3 10.5. And the last one here, 3.5 times 4, that's 14. We get the ordered pair 4, 14. So then on my graph, one thing that's a little different about story problems, I have to label my axes. It's very important that I do that. So X, remember, stands for seconds. That's going to be on my y-axis or x-axis, and Y stands for the distance the mouse can run. So I'm going to put distance over here on the y-axis. Okay, for my seconds, I have 1, 2, 3, and 4. And I could put, whatever values I pick, I can put them on here. And then I have to get up to 14 in distance. I'm going to count by 2s. 2, 4, 6, 8, 10, 12, 14. Okay? And now what I'm going to do, I'm going to plot my points. So I have 1, 3.5, 2, 7, 3, 10.5, and 4, 14. Now, my mouse is running this whole time, so I can connect my dots. Okay. And then, what I want to do for the last part, so I got my table, I got my graph, I got my axes labeled. The last part is estimate how many meters a mouse can run in 2.5 seconds. So on my graph, I'm going to find 2.5 seconds, which is right here. And I'm going to go up to where that intersects my line. And then I'm going to go over. Okay. Now, notice here, it looks like about 9 well, right about 9 actually, because here's 8, here's 10. We're kind of right in the middle. So about 9 meters would be my estimation for how far the mouse can run in 2.5 seconds. Okay, and again, I know that I could just do 3.5 times 2.5 and get an exact answer, but that's not what I want to do here. I want to use the graph to estimate. Okay, and that's what I did here with my line. So this would be the work I would see on your story problems. I would see a table, I would see a graph with your axes labeled, and then I would see your estimation piece here with the dotted lines. Alright? So, again, pretty much 3 things. We go back, we have the function with the given domain, where we solve for y, make a table, plot the points but don't connect them. Then we have functions with a domain of all real numbers. We make a table using -2, -1, 0, 1, and 2, plot our points, and connect them. And then we have the story problems where we have to make sure that we choose reasonable values for x, at least 4 of them. Make our table, label our axes, draw our graph, and then use our graph to estimate. I have plenty more examples of this stuff. If you need to see more of them tomorrow, just please let me know. Otherwise, we'll see you tomorrow.